All right, so I want to find the area of an enclosed region. This is out of our textbook, section 6.1, number 21, Stewart. And I have four curves going on. I got y equals cosine x, which we remember is some sort of sinusoid. It's actually that sinusoid. We got sine 2x, which remember has a period of 2. All right, we'll do that up here in a second. And we have two vertical lines, x equals 0 and x equals pi over 2. So we'll do this all in a graph. We're going to have to do this to scale. All right, we're going to have to remember our parent functions. Cosine x is probably the easiest one, and I'll try to do this to scale the best I can. If we make this 1 and this negative 1, all right, remember pi over 2 is 1.57. You guys agree? 3.14 divided by 2. So if you think of it, the line pi over 2 is somewhere about there. The line x equals 0 is the same as the axis, right? And then I'll do the cosine x curve next. The cosine x curve, if you don't recall, starts at 1, goes to 0, goes to negative 1. And if you wanted to finish it, remember it would come back up to the same spot in 360 degrees. That would be the cosine curve, and that is the parent function curve. All right. I'm going to, in purple, do the parent function of sine x. So I'm going to graph first, and I'm going to move it off. I'm going to graph this first, because if you don't remember this curve, it's almost impossible to do sine 2x. Yep, 0, 1, 0. Oh, sorry. I'm a little off here.
Isn't pi over 2?
I'm off on my curve. Pi over 2 should be...
Yeah.
My green curve is off. Let's back up. I mean, whoa.
Too much back.
Let's back up. I plotted a point wrong on the green curve. All kinds of problems. Let's get this out of here. I am right that it has to go 0, 1, but it's where I placed it, right, Megan?
Yeah.
This 0 should be right here. That's pi over 2.
Yeah.
All right. And then pi would be negative 1. Try to keep the same distance. That'd be over here. Pi over 2, and then 1. Again, it looks the same, but our graph was a little off otherwise. All right. Because we agreed that this is 90 degrees, or pi over 2. This was 0 degrees. All right. Going back again. Let's try this again. Y equals sine x. Sorry about that. We know it goes 0, 1, 0. There's half of it, right? And if I just finish it, it looks something like that. But guys, that is not the curve we have. That's why I don't like the graph. That's why I said we're going to change this. That's the parent function. Remember, when you have a multiplier inside, it makes the curve happen more quickly. So we're going to take, basically, I like to think of an accordion, right? We're going to hold this wall at 0, like a fence, and we're going to smash this purple curve in. We're going to smash that purple curve in so 2 of those curves occur in 360, all right? Or in the 2 pi. So if I do that in dark blue, it means I would do this curve that fast. That fast. Yeah, I'm really bad at it, but it was going to happen much faster. It's going to happen 2 times in there. So we're going to take out the purple curve and put that in. All right? So we thought of our parent function. All right? We thought of our trig. And again, if you have a graphing calculator, and you should get one, if you're not, again, when we get to the AP, trying to get some lined up. Borrow one. We're going to be using them. So my curve starts at 0. And at pi over 2, it's going to be 0 again. All right? And in between, it's going to peak out at 1. All right? Now, everybody, I see 2 areas. All right? I'm going to use different colors to shade them, I hope. All right? What I see here is I see a region right here. All right? And I see a region right there. It isn't going to matter, except if you do them net together. If you try to go from 0 to pi over 2, one area is going to be positive, one area is going to be negative. And you're going to get the difference when what I want is the total area. So this is one of the times we're going to have to figure out this point C, the intersection point in between. So we have some math to do here, because I cannot do the integral from 0 to pi over 2 and say f of x minus g of x, because they switch upper and lower curves. To find the total area here, I am going to have to take the time and find this point right here, which I'm going to call point C, in between A and B, right? So, everybody, to give you a feel for what this looks like, when I did this graph, you're going to have to be able to do some of this graphing to figure out what's going on these curves, all right, when you start doing practice problems. Hint, hint. And here's what I know. I know that I can tell initially the cosine curves on top. You guys agree? So I can say the area between these curves initially starts at 0, right? And it goes to C. I don't know the value of C. We'll come back to that in a second. The initial curve on top is cosine x. The initial curve on bottom is sine 2x, what? dx. You guys agree? Then we have to do what? Well, we gotta change. Now it goes from what? C to what? Pi over 2, but something happens. The curves flip-flop. Now the sine 2x curve is on the top. You guys agree? So I gotta go sine 2x minus cosine x dx. And now we have to find, I think our next step is to find C. All right, that's the integral. I just have to define C. And everybody, I would say it this way. C is the value where y equals y between 0 and pi over 2, right? Where that means cosine x equals sine 2x. Now, I am not interested in doing this longhand. Are you guys? All right, and this is where our graphing calculator becomes really imperative on some of these problems. We can tell our calculator to solve these problems. All right. If I pause the video, I'm going to get the calculator screen in there, okay? All right, so I think the easiest way is to put in the functions. Cosine x, right? The other curve was sine 2x. You have to be in radians, so I go to the mode. And, of course, my calculator's in degrees, so I put it in radians. I go to window. I'm going, I don't want to go to 10. I'm going to go 0 to 3 on x, right? Because it's just, that's like, that'll be 0 to pi. And I know that it goes from -1 to 1. So I don't need to go any further than that, I don't think. I can come back and change it. If I hit graph, there's the cosine curve getting drawn. Here's the sine curve getting drawn. All right? And there's the two regions we talked about. All right? And if I fill them in right now, we're talking these two, oops. Yeah. Those two regions, all right? By touching the board, I made it get bigger. You can do this, all right, by telling it to go under calculate, second calculate, and you guys can find an intersection, number 5 there. And it's not always number 5, it's whatever it is on your calculator. Enter, and it's asking you to give a guess. What's the first curve? Right now it says up here, you can barely read it, y equals cosine x. All right? And I'm going to get a little closer to my intersection. Yeah, I want y equals cosine x. I hit enter, and it says y equals sine 2x up there. Yeah, that's what I want. Now it wants you to guess the intersection. Well, I'm going to get closer here. I guess right there. And everybody, my C value is 0.5236. It says 0.5235, and I don't know if I autofocus if it'll get a little better. Oh, there it goes. 0.5236. How's that for an annoying value of C? Everybody, this is now becoming a problem. I do not want to hand integrate. You guys agree with me? But we have C equals 0.5236. Well, I write all the digits, right? 52. There. Everybody, this is doable now, though. I mean, if we want to do it by hand, it's possible. We can do these integrations. So I'm going to do the integrations by hand. And often on tests, this is what I would say. Integrate, but do not evaluate. That means to do the integration, but don't plug in the numbers. I don't care enough about what the actual value is. And your calculator will do this calculation, will work on that too. So if I'm going to do that, I would leave C up here, and I would write C. I would not put in the decimal in my integration. I'd leave C. Is everybody, that's good enough. Everybody, we got to do the antiderivative of cosine. Well, I think if we think about it, we all agree that the derivative of sine is cosine. So the antiderivative of cosine is sine. Minus. Now this gets a little harder, all right? I think this is going to be plus 1/2 cosine 2x. And this takes practice. Guys, we knew the derivative of cosine is negative sine, right? So the derivative of cosine 2x is negative sine 2x times 2. That is the antiderivative. What? Evaluated from 0 to c. And I can write a equals. Then what's the next step? Well, we got to do the same integration on the other one. Plus, well, we already know the derivative is of sine 2x is negative cosine, negative 1/2 cosine 2x, right? Minus sine x from where? From c to pi over 2. Guys, if you have a calculator, this is not that hard a problem, right, to do. I mean, you can put it in radians, you can get all these decimals, but this is a case where we would just stop and say, that is the area enclosed by the curves, all right, and that would be the value of this answer. But the hard part here, again, I come back to, I think the real legwork up here is finding which curve is on top and which curve is on the bottom, and then understanding that they flip-flopped, right? So you had to find a point of intersection of them and divide the integration into two parts. Essentially, you got to have a decent graph. I mean, I don't think any of us would know without a picture that these intersect, including myself. Without that picture, I don't know these intersect.
Can you do the negative sine x and antiderivative?
This one? So the way I think of sine, so you have sine 2x and you want to do an integration of it. All right. So if I do this by u substitution, because if you're struggling to see it, this will help. So u equals 2x. Do you agree that du is equal to 2 dx? All right. So then I can write this as sine u. I'm going to have to put a 2 with the dx. You agree? And I'm going to have to put the half out here. Because 2.5. So now I can write 1/2 sine u du. And then we think to ourselves, we know the derivative of cosine is negative sine. So if you put the sine on the other one, the antiderivative of sine is negative cosine. So 1/2 times negative cosine u, and then replace u. So that's why we get negative half cosine 2x. All right. Keep practicing. All right.